Hello, everybody. My name's Andy Coote. I'm the Chief Executive of Consultingware. We're a small specialist management consultancy working in the field of geospatial information. And what we're doing today is this is a first of what we hope will be a series of discussions, I think is the best way to describe them, between either myself or somebody else as the host and one of our subject matter experts. And what we're trying to do here is to build up a body of knowledge that we can share with others who are practicing around this area of 3D geospatial information to increase the number of people who understand the concepts and to build up a body of knowledge. And I'm delighted for this very first one that we've got with us today, Ralph Coleman, who is commercial director at Blue Sky. And I'm going to start off, first of all, Ralph, to ask you to describe your role and your background and interest in 3D geospatial.
Sure. Thank you very much, Andy. Delighted to be here to have a chat with you about this. It's a great topic and one that needs, I think, a bit of, as you rightly point out, demystifying. So I think it's a really good start to this series of podcasts. So as you say, Ralph Coleman, Chief Commercial Officer at Blue Sky International Limited. I've been with Blue Sky for 25 years, man and boy, more or less. I got a geography degree, always been in sales. I've always had a real interest in how geospatial has worked in the third dimension. So I've been licensing and selling 3D geospatial products for more or less the whole of those 25 years to a whole range of different market sectors, predominantly initially government, but then out into the commercial sector as well, engineering, environment, and surveying, architecture. So quite a broad sort of background in 3D geospatial. And more recently, we've been moving quite quickly in the geospatial world, and I'm delighted to be part of the AGI 3D special interest group that I think this will probably be part of when we put these podcasts out.
Excellent. Well, that's you're the right person, I think, Ralph, to have in the room. And so I think what we'd like to start with is why today we're going to talk about terminology. Why is terminology important to us? Surely we all understand it.
Well, you'd think so, wouldn't you? I think one of the main problems with 3D geospatial at the moment is the amount of terminology that's out there, the amount of different definitions we have. And I think it can be confusing. It's certainly inconsistent. It's inconsistent across lots of different industries. It's creating confusion in the market, which is the last thing we want. And quite often what it does is it creates unrealistic expectations from customers, which certainly as a salesperson, that's not what I want. So I think if we look at it from a technical perspective, there's lots of different words that describe very different technical data structures, for example, different accuracies, which again is very confusing. And I think what that does is it creates a landscape in which we can't really concentrate on the important thing, which is the outcomes here. If we're looking at buzzwords and technically complicated terminology all the time, what we're not doing is concentrating on those really, really important outcomes and the value that 3D geospatial brings. So look, I'm not sure whose responsibility this is and how we're going to sort it out, but it certainly needs sorting out. And I think it needs sorting out quite soon. I think one other thing I'd like to say on this, if we're talking about this demystification, is we shouldn't perhaps get too wrapped up in standards. I think we're not talking about standards here, and standards is something completely different. When we're talking about standards, we're often talking about metadata, we're talking about taxonomy, we're talking about formats and that sort of thing. And I think what is quite interesting about 3D geospatial is we've also almost got a better handle on the standards than we have the terminology we use to describe it. And I think that's probably the wrong way around. So I think there's a bit of work to be done there, certainly.
Yeah, and I think that the other thing with the terminology is that we've probably never managed to harmonize it completely because we've got different industries colliding here. So we've got, for instance, the video games industry, and they've got a whole bunch of terminology that they use, which is very, very similar to the terms that, in the content that we have, but they use different terminology. similarly, I think if you look at the way in which even closer to home, like the marine geospatial people, they refer to, for instance, the term digital twin to mean what I think we would call a spatial data infrastructure. It's something that is persistent and it provides an overall framework. But they've chosen digital twin as the term that they want to use. But I think, to me, Ralph, the most important thing is, as long as we're clear with our audience what we're talking about, then at least we're not passing like ships in the night where we think we're talking about the same thing, but we're talking about something completely different. So
indeed, yeah. You use that term digital twin, Andy, that divisive term digital twin. And I think, depending on who you are and what your background is, what your area of expertise is, it can mean a different thing to so many different people. From a purely sales point of view, I haven't got a problem with it being used for a really broad range of different things, because if I can relate to my customer base, with a term, then that's fine. I'm happy with that. But I think we do have to be clear about what we're talking about when we're talking about a digital twin. And if we're talking about a digital twin, it does need some level of classification of what type of digital twin it is.
Which I think then brings us quite neatly to the next thing that we wanted to talk about, which is around, the object model, if we can call it that, of a 3D digital output. And I know that you know a lot about these different, what are known as levels of detail. And perhaps you can just talk us through, without getting too deeply into the technology, what this is all about.
Yeah, so object models, LOD models, photogrammetric models, semantic models, again, there's a whole range of different terms for this. And hereby you can see the problem we're dealing with here. But look, I think LOD models have been around for a long time now. And I think we do have a fair amount of clarity about what you can expect from each level of detail at the moment. And there are some blurred edges, Andy, don't get me wrong, but I think if we're talking about an LOD1 model, we're usually talking about a fairly simplistic block model, an extruded 2D model with a height, looking at probably a larger geographic context, a more contextual type model. If we're looking about LOD2 to LOD3, we might be talking about something that has a bit more roof detail, some detail on the facades. We might even have some semantic attribution in an LOD3 model, for example. Something a bit more accurate potentially, that has a few more, has a bit more detail on it, and that might be used a bit more for urban analysis or some more detailed planning purposes. And then we're down to sort of LOD4 plus, and then we're talking about something that might have interior attribution. We're talking about rooms inside. We're talking about potentially a temporal element to those models as well, possibly with LOD4. So we're talking about something that would probably be limited to a specific building rather than a city or a town or a region. So they're largely the descriptors of the LOD models, or LOD models, as some people like to call them. But I certainly don't favour that terminology, Andy.
But the thing that I think is great, Ralph, is that there is, because you can get, we could even put into this video some pictures of those different models. That graphical representation cuts across the language things. And so therefore somebody who actually creates physical 3D models, like, for instance, they've done at Nottingham, they would understand level of detail. And I think also people in the medical field would understand that as well. So we've got if you like, a building block with the idea of levels of detail, I think, which can overcome some of those semantic misrepresentations or different representations that cause us grief. So
I think that's very true. Yeah, very true, Andy.
So let's start at the beginning of the process, Ralph, which is the acquisition of the data. And to me, we've got something really exciting going on at the moment, which is, if you like, creating a continuum right from satellite imagery, which obviously is quite low resolution, right through aerial, and right through to drone. And those are starting to, boundaries are blurring depending on the use case, the accuracy that you actually need, and as you say, the geographical coverage. So can you talk us a bit through where you see that going, and what are the useful bits of terminology that we can grab onto?
Well, I think you've almost described it really well yourself there, Andy. Actually, there is a lot of excitement around how we fuse these different data sources in the 3D geospatial world. So if you look at satellite-derived 3D models from satellite content, you're talking about a really regular return period. You might have monthly, weekly, or even daily return periods. But what you're talking about is a model that's got a lot less spatial resolution than, say, drone or an aerial platform. So you'd be looking at that over really wide geographies, large geographies where you don't need that high level of accuracy. And then right to the other end of the spectrum, you've got the excitement of capturing 3D content with drones now, or content that could be turned into 3D data from drones. That would be the other end. So you'd be looking at individual buildings or small pieces of infrastructure where you've got a massive amount of photos being collected and having to be brought together in a photogrammetric environment to create this 3D content. But you've got a very, very high level of detail. And then, in my opinion, as someone who's more of an expert in manned aerial capture, you've got the sweet spot in between where you've got high accuracy cameras and instruments capturing really good quality aerial photography or LiDAR data that can then be turned into 3D content across cities, possibly regions, and actually whole countries as well. So I think what the future might hold here is a combination of all those different sources and bringing those together. You've got the return period of a satellite, you've got the very, very high resolution of a drone, and then you've got in the middle high accuracy but large geographic coverage of manned platforms. So that's certainly the future, as you alluded to.
Yeah, and also, of course, with the aerial platform, and to some extent with drones these days, you can start putting different sensors onto the same platform. So you can
Indeed.
you can have optical, but you can also have hyperspectral, and that opens up so many more, to me, applications, use cases where you can bring together those different sources to provide answers to bigger problems like, our housing crisis, climate change, and all of those kind of great applications that we can address. I think one thing, Ralph, that would be really useful in terms of terminology, and you've started to use the terms when we talk about digital photogrammetry, and then we talk about other techniques of processing the raw imagery through into something that's usable. Can you just unpack some of those terms for us and explain them?
Yeah, as you rightly point out, I think photogrammetry is the most traditional, probably, methodology of creating 3D models. The traditional way of having stereo photography and having people sitting at a machine using a plotter and just plotting in 3D, which still happens a lot to create 3D content now. But then, of course, you alluded to it there, Andy. You've got airborne platforms that have LiDAR sensors in them alongside oblique and vertical aerial cameras that can capture all of those data sets simultaneously. And that can bring a completely different element to the 3D content. So you're able to capture the facades of buildings, the nadir, the tops of buildings, but also LiDAR, which gives you a completely different level of accuracy, all simultaneously, to create what we'll probably move on to in a minute is these really impressive 3D mesh products that you see in the market now. But all of these different capture technologies have slightly different outputs. They have slightly different applications, and I think it's really, really important that us as experts are advising our customers which is the best technology or the best capture technology that will enable them to meet their needs and solve their problems. So again, a little bit like the different modalities we talked about a minute ago, using some of these techniques in conjunction with each other is often the best route to get the best output.
And I think my problem on behalf of the users, Ralph, is that every few weeks you seem to see something new come out as a piece of technology which would appear from the purveyors to wipe everything else off of the off of the map. And it is difficult, I think, for users to understand, is this the greatest thing since sliced bread, or is it just changing the parameters, having more AI, more compute power to throw at things? So what's your sense of where the software end of things? So you're specialists obviously in the capture, but you also use a lot of technology then for processing that to make it application ready. Where do you see it going?
Well, this is something that's actually come a long way in the last few years. It's only been a few years since we were creating 3D products that actually weren't usable for our customers, and that was a real concern. If anything, we were a little bit ahead of the market. We were a bit ahead of the software vendors, and they couldn't handle a lot of the models we were generating. But now you find that most of the large GIS vendors have software that's very able to handle some of even the largest 3D data products. Of course, cloud storage has helped significantly with this as well. Streaming technology has enabled users without the capability to hold this data locally, enabled them to bring that onto their desktop and use that with their other data products. And I think one of the most exciting things about 3D now is it's so much more accessible than it was just a few years ago. And I think we had a real challenge with that only a few years ago, and that's really made our jobs quite a lot easier, albeit we're still not quite there yet with the accessibility piece, and there's some more work to be done. But I think that the customers being now enabled to fuse their existing data with new 3D content in the market, whether that's data they've sourced from a third party or whether it's open data or whatever, is a really, really exciting prospect.
Yeah. So we've got this merging of different data sources and applying them in different ways, which takes us to where I think we were going next, which was around this whole idea of mesh models, and maybe demystify a bit of the terminology around that and how that's different from the object approach.
Yeah, well, look, meshes aren't a new thing. Meshes have been around for 25 years, probably longer. 3D geospatial meshes, in fact, have been around for a long time, but they suffered very much from the challenge that we've just spoken about. They were very, very difficult to handle. They're very, very large file sizes, difficult to consume. And the way they differ from more traditional object models is they're a continuous surface, whereas object models are exactly as they sound. They have individual objects, they're individual entities within a model. Meshes are one continuous surface, often augmented with aerial photography. So they're just a continuous surface of triangles that have got an aerial photograph essentially pasted on top of them. They're visually incredible, beautiful things to look at. They don't always have the same accuracy and fidelity as object models, or they can do, but they don't always. And I think we're really seeing the development now of an understanding, should I say, of where these different models should be used. So I think the majority of use of meshes now is as context. We're looking at broader 3D visualizations across whole cities. What we're then seeing is meshes, object models, and other 3D data sources, in fact, being merged together and put into one 3D environment. And then you can leverage the capability of all of those different types of data all in the same environment. And that's when we're sort of moving towards this truer representation of a digital twin, as purists would talk about, where we can see that we can start to look at updating these 3D environments, these city 3D environments, and that's when it gets really, really exciting. So to update a mesh very regularly is quite a technologically tricky thing to do. To update object models is far more simple. So if you use those two things in combination, you're getting something that's much more exciting.
Yeah, and I think that brings us really neatly to the fact that although, arguably the UK is not as far forward as for instance, cities like Helsinki, Munich, and a few of the other big European cities. We have got some beacons of hope out there, and I know you've been involved with some of them, Nottingham, for instance, but other areas. Do you just want to talk about some of those really good reference sites where exciting things are already being done?
Yeah, I think, look, we know that Nottingham's a well-trodden path, and those guys certainly are a beacon. I think where they've really excelled is they've looked at all of those different modalities and they've used them in the right place. So, and they haven't, although a lot of what they've done is come out of planning, they haven't sought to simply just concentrate on planning. They've looked outside of that box and they've looked across the whole of the authority at different departments, and they've sought to engage across the whole local authority, talk to infrastructure, talk to heritage, historic monuments, talk to energy companies, talk to the utilities, and try and really create a community that are using this single source of truth to work together to create this asset. And we talk about Nottingham a lot because they are a great example, but there are other great examples. We've done a lot of work with Boston over in the US as well, who are another great example of using lots of different 3D data sources together to create value. We were involved in a Singapore project through our new owners, in fact, Woolpert, who won that project out in Singapore, and we were involved in acquiring that data. Singapore are streets ahead of a lot of other cities with their vision to create a digital twin of the city, a living, breathing digital twin that can be updated, that can be augmented with the Internet of Things, sensors in streets, sensors in buildings, all of this sort of thing, which, a few years ago looked to be completely futuristic, but now is actually being brought into reality. And it's really, really exciting. But all of these things need a spatial anchor. They need a canvas in which to build this rich environment, this rich connected environment. And that's where I think what we do in the 3D geospatial world, it is so important in creating that canvas where all of these exciting things can be placed upon.
That's fantastic, Ralph. That takes us right back to the beginning. It takes us to the point that you're still going to need geospatial people.
Oh, yes.
We're not about to be replaced by AI, I don't think, anytime too soon, although it's a great enabler. So Ralph, thanks for that. That's it. Brilliant. No need for retakes or anything. You're a natural.